Okay, this is the study guide video. Check your work. Write down the 5 words that show me that you listened. But this first one right here, know that that has my letter marks. Tells me that this is the starting triangle. This is where it's starting, and this is where it's ending. So don't mess that up by starting in the wrong spot. One of the most common thing was for someone to take that triangle and then reflect it across that y-axis. That's probably your number one thing. Either reflect across the x-axis, and that is the y-axis, I'm sorry. So reflect across that y-axis going up and down. And then it looks like after that, I'm doing a rotation, which is going clockwise if I'm doing this one first. Then rotate 90 degrees clockwise around the origin. That's one way of doing it. Another way would be to take that triangle and reflect across the x-axis first. If you reflect that across the x-axis first, if I wrote that, reflect across x-axis, then my second part would be to rotate, but I'm rotating from here, I'm rotating counterclockwise. Again, remember this piece right here, this stretch will rotate all the way to here. So remember that whole little rectangle rotates and moves that point over when I'm doing my rotation. So again, what I'm trying to say on this one is after reflecting across the x-axis, if you do that first, then it's a rotate 90 degrees counterclockwise to the left about origin. So again, you're looking for an answer like that. All right, here we go. Next problem, number 2. For this one, again, you're looking at which of these is true. I know that this one right here, D, is the midpoint of AC. So it looks like that point D is halfway. So I know that's good. It looks like the line segment EB bisects the whole line segment AC at that point. That one also looks good. So just know on this, don't just say 2 answers. If both of those are legit, make sure you're telling me that. Both those answers are good. Both those are true. So let's get rid of that last little one right there if it lets me. And let's take that and say both answers are true. All right, let's move on. Next, this guy, looking at these, trying to help you out. First word is red. Thanks for listening. All right, all 3 corresponding pairs of sides are an equal measure. That means you have 2 triangles sharing 3 sides, side, side, side. That is yes, for sure. Remember all the good ones. Side, side, side. The sandwich ones. Angle, side, side, angle, side. The double angle and a side. And then remember the not so good ones. No, you got angle, angle, angle. That's proportional but not congruent. And then you got the SSA written, the bad word, ass. That is no good either. Those do not show congruency. All right, at least one angle is a right angle. So that would be like just A. And none of those have just A. So that one's no good. This one says all 3 corresponding sides are in proportion. And what that means is if I take a triangle and I take a corner of it and I stretch it, it makes it proportionally bigger. It has the same proportions, but it's not the same triangle. It's not congruent. All of these have the same proportions. They're all proportional, but they're not equal. They're not congruent. Proportional, similar. That's what we call these. All right, next one. 2 pairs of corresponding angles are congruent. So angle, angle. And again, that one is no good. And then the last one. a rigid motion, like one rigid motion, like doing a slide. Let me try to show you. If I took this one and took another, and then just one slide, if my pen lets me, right? In one slide, if I take that and move it on top of each other, that proves they're congruent. So when one rigid motion, like a slide or a reflect or a translate or a flip or a rotate, covers itself up, for sure that's enough to see if the triangles are congruent. All right, moving on. Number 4, this one. Again, angle, side, side. This is angle, side, side. That is not one of your good ones. Remember, all your bad ones, angle, angle, angle's no good. Angle, side, side is no good. And then all your good ones, side, 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 angle, side, angle. You got angle, angle, side. Then you got the other sandwich one. Look for the sandwiches. Side, side, side for sure. If I have 3 S's on that one, side, 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 I know that one is true. All right. If I have a rotation, yeah, let me show you why a rotation works. If I took this triangle and I rotated it, you should see that the bottom triangle should exactly cover up the top one. So in one spin, a 180 spin, it covers itself up. So that proves that a spin, a rotation, will carry one triangle onto another. And then the last one, a rigid motion, like a translation, I can show you why that doesn't work. If I rotate it, it covers itself up good. But if I took one of my triangles and just tried to slide it into position, it will never cover up the other one with just a slide. I would need to rotate too. So that one is false on that. All right, moving on. Number 5, knowing the correct marks, and we'll practice one last time. This one has the correct marks for marking your angle and then using your compass to measure these pieces right here. For a perpendicular bisector of a line segment, you're not doing angles. That's line segment XY. So don't pick any of those angles. This is the only one that has it bisect, which means cut in half. This one is clearly not chopping this piece in half, so that's why we don't want you to choose that one. That's not a perpendicular bisector construction. All right, moving on. This one, know that this is the starting line. This is where it all starts, the equation that looks normal. The one that looks kind of funny, this is the finish line where it all ends. So I'd like you to plot the starting line on the graph. So find -3 on your graph and know that these slopes, that over 1 down 3, they're always going to be the same parallel slopes. For these linear transformations, all you're doing is either moving the line up or down the y-axis. So you can see if it's starting here and it's ending up there, it's moving up. And how many boxes? 1, 2, 3, 4, 5, 6, 7. What is the K number? 7. What is it doing? It's shift up 7. That's what I did. I took the original down there at -3. I shifted it up 7, and it gave me the new equation's y-intercept, which is f of x equals that same slope, but not +3, not +7, +4. And I get that 4 by moving up 7 boxes from -3. That's where I end up at +4. But this one is just asking about the starting line and what am I doing to get to the finish line, shifting up. All right, next random word is dawn. All right, here we go, next one. This is the original, the starting line. That line, that x, is really 1x plus 0 in disguise. A lot of people don't see that. So if I graph that starting line at 0, I'm going over 1, up 1, over 1, up 1, but you can see I'm plotting more than 1 point. It only wants 2 points. It will mark you wrong if you graph all those dots. You could only graph with 2 dots. So again, let me try to show you that. That would be like starting at 0, and then I could do over 1, up 1. I could just do those 2 dots right there as my starting line. Remember, that line is the starting line. Those are my 2 dots. And then I'm looking like I'm shifting up 2. So up 2 on that y-axis. And again, draw that line. Same slope, over 1, up 1. But just realize if you draw 3 dots, it's going to mark you wrong. Only 2 dots. You could do these 2 dots only. That would be good. You could do further up, but on the same line, pair of dots if you want to do that one too. But that is the finish line. It's moving up 2 to get to that new. Graphing with only 2 dots each. Look, only 2 dots I used on that one. All right, next one. Number 8, or number 9. This one, they want you to make a square. On the final, I think it's going to be a rectangle, so not all the lengths are going to be the same. I'll try to show you. But for this, you could either find the slope between these two and then do the opposite reciprocal through that point. Or you could do, let's do that again. You could find the slope of these and then do a line perpendicular to that to find this point over here. That's one way you could do it. Another way you could do it is find this slope between those 2 dots and then do a perpendicular slope to that to get that 4th point. There's another way you could do it too. You could find this slope and then from here do that same parallel slope to get another point. But I'm going to do perpendicular because that's kind of what they want you to do. So if I look, this line right here is going over 1, 2, 3, 4, 5, going right 5, up 1. That is the slope of that little line segment. If I come at it at a perpendicular angle to make 4 right angles for either a square where you have 4 right angles or for a rectangle with 4 right angles, you need to have those slopes be opposite reciprocals, -5 over 1. That means I need to approach a line through Z using that ratio of over 1 down 5. Of course, if I go over 1 down 5, it ends up down here. That's not what I want. So you're going to have to stair step the opposite way. You're going to have to go left 1, up 5 to get your 4th possible point. So if you look, that would complete my square. That line that I drew between those has a slope of -5 over 1, which is the opposite reciprocal to this 1/5 slope right there. And now the last part is to write that coordinate, which like it's going over 2, up 4. Write those coordinates in the right spot. Over 2, up 4. All right, moving on. Number 11. For this guy, find perpendicular lines where the slope is opposite reciprocal. Like if I have 5, the opposite reciprocal is -1/5. So again, you're looking for something like that. And again, that's the answer right there. This has +5, and then the other one -1/5. That's why this is perpendicular opposite reciprocals. This one is just opposites, not reciprocaling. This one is just opposite numbers, not reciprocaling. This is just opposite, not reciprocaling. I need a flip-flop and opposite. Opposite reciprocal, so only D. All right, the next one, another kind of problem like that. If I give you 3/4, I want you to be able to see that the answer isn't just it flipped over, isn't just opposite, it's opposite and flip, opposite reciprocal. So the only one on there that has a true opposite reciprocal, -4/3. This one is that person who just opposites. This is that person who just flips it. This person just left it alone. Those are no good. Opposite reciprocal. All right, moving on. Number 13. For this one, find the perimeter, knowing that the bottom 1, 2, 3, 4, 5, 6, 7, 8, 9 is 9 boxes long. That's going to be one of my numbers I use for perimeter, which is adding up the length of all the edges all the way around. That's perimeter. So that piece is 9. But you can see this little triangle has a base of 4. If I count this one, 1, 2, 3, 4, 5, has a height of 5. This one has a base of 5. So I'm going to use Pythagorean theorem to find this length right here. We'll call it C, I guess, by using the Pythagorean theorem, using that 5 and 4. So here I go. To find that first C, C squared, always square it, 5 squared plus 4 squared. That gives me C squared is 25 plus 16. Gives me C squared equals 41. I'm going to square root it. That makes that square root symbol disappear, and then I need to round it to 1 decimal place. So if I square root 41, that gives me 6.401, rounding to this 1 decimal place. That 0 is not enough to make that 4 go up by 1, so that stays 6.4. That is this length right here. Now I just need to find my last length, which is this one right here. We'll call it maybe the green C. So that one comes from C squared equals 5 squared plus another 5 squared equals C squared equals 25 plus 25. Don't get no 10 there. Gives me 50. And then I'm going to square root 50. My pen lets me draw a square root, which cancels these away and leaves you just plain old C. And then when I square root 50 on my calculator, that gives me my answer. So square root of 50 is 7.071, rounding to 1 decimal place, makes that 7.1. So that length right there is 7.1. And now what I need to do is find the perimeter by adding them all up. So here I go. I'm going to add that 9 plus that 7.1 plus that 6.4. Let's see what we get. So 9 plus 7.1 plus 6.4 gives me 22.5. Don't worry about any units because they're not giving you any units. Perimeter. All right, moving on. 14. For this one, again, put the numbers where they go and look for the hole. 101, put 103 there. Put 106. Put 107. Put 109. Put in there 111, 115, 117, and 119. Let me show you how this works. That middle number, that 110 number that we're getting right here in the middle, 110, which is the median of the entire set. I get that by adding these two numbers up and dividing by 2. So if I take 109 plus 111 divide by 2, that's where I get 110 in the middle. And then you should be able to see with the other medians, here's a median right here, here's a median right here. You should start to see the structure of this. On the left side, I have 5 pure numbers. Count them. 1, 2, 3, 4, 5. If I look at this right side here, I only have 4 of them. That's where the hole is going to be. And then let me try to show you more of the structure. On either side of the median, I have 1 number on each side. On either side of this median, I have one number on each side. But when I look at this median, it only has one number on this side, where this side has a hole in it. There's no number right there. That's where the hole in the data is. That's why if I put like 113 here, it will keep my thing intact. It won't change the box and whisker plot. But if I instead try to shove in a number like 116, then that would change this median to have to be over 116. You don't want any of the medians changing. You want to only fill in a number that's in this hole. So I could use 112, 113, or 114. Any of those three numbers would fit in there and not change the box and whisker plot. All right, next word is black. Black. All right, here you go, 15. This one says the range of high temperatures is smaller. So if I look at the range of the high temperatures, 80 minus 40, looks like the range is 40. If I look at the range for the low one, 60 to 30, looks like it's 30. And there is no way that's a true statement. 40 is not smaller than 30. All right, next one. The difference between the medians, the median is the middle line of the box. So this one says 55, this one says 40. The difference between 55 minus 40 is 15, and since this one doesn't say 15, that's why this one's false. And then the last one, the interquartile range is the range of the box. So if you look, this is going 35 to 50. That interquartile range is about 15 for the low one. And if I look at the interquartile range for the high one, looks like 10. So the interquartile range for the high 10 is larger than the lower. That is another false statement. Knowing on the final, one of these will be true, or at least two. It's not going to be all false. All right, here we go. Moving on. 16. I want you to describe both of these, and here's what I would write. Stay stay safe. A is skew, and even though it's pointing to the right, we say skew left. It has more high scores. If you want to be technical, that means if you have like a 3-number set, like 1, 8, 10, that means the median number, this is my median, is going to be higher than the mean. The mean is when you average the 3 numbers and divide by 3. So if I look at something that's skewed to the left, even though it looks like it's pointing to the right or sloshing to the right, I get a number that has a mean less than the median. That means the data is like sloshing more to the high side of your data. If I have the C one, C is skew, and again, I know it's kind of misleading because you look at C, it looks like it's sloshing to the left, but we say skew right. Oops, let's put it there. It has more low scores. To try to show you what I'm looking, if I gave you a 3-number set like 1, 2, 10, then for this one, a skew right has the median be smaller than the mean. Because if I take the mean of this one, 1 plus 2 plus 10, divided by 3, that gives me 13 divided by 3. That's a median of 4.3, and you can see that is more than the median. So when the mean is more than the median, that means it's sloshing to the right, it's skew right. When the mean is less than the median, that's skew left. So if you want to talk about that, feel free, but this the main things. Skew left, more high scores. C, skew right, it has majority of lower scores. Or if you want to be high tech, skew left has the median higher than the mean. Skew right has the the median lower than the mean. All right, here we go. I know a lot of talking. 17. For this one, two-way frequency table. Looking at this first one, Spencer won the election with exactly 60% of the votes. So I need to find the total for Spencer. So total for Spencer was 300 divided by the total of the entire set. So for that one here, if I could clear that up a little bit, that gives me 300 divided by the total of the entire set, and that does give me 0.6, which is 60%. So you can see that is exactly, he won with exactly 60%. All right, next one. Approximately 70% of the 12th graders voted for Spencer. So for this one, a little bit different. You're not looking at the total of the entire table. You're looking at the total of the 12th graders, which is that 220 number. And then you're comparing that to the number of 12th graders that voted for Spencer. So that would be 130. If I divide 130 divided by 220, that gives me 0.59, and I can see that is not approximately 70%, which would be 0.7. All right, next one. Exactly 72% of the students, total students, so total students again is that 500 number, but we're in 11th or 12th grade. So this one's a little trickier. You need to add up these two numbers, the total of 12th and 11th graders that voted in the election was 220 plus 140. And if I add that up, I believe that gives me 360 over 500. And if I divide that out, that gives me 0.72, which is 72%. So that one is money. All right, next one. 50% of students who voted for Jules. So you need for this one, the total for Jules, which is this column right here. The total for Jules is 200. And I'm comparing that to the total of 9th and 10th graders who voted for Jules. So these two numbers will give me the total of 9th and 10th graders. So you can see that gives me about 70 over 200. And if I divide 70 by 200, that gives me about 0.35. And you can see 35% is not approximately 50. All right, moving on. Next one. One more two-way frequency table. So it gives me the total that always goes at the bottom right. And then it tells me what to do with that total. 15% of the total students did not like ice cream. So the do not like ice cream total is going to go right here. That's where the do not like ice cream total is going to get. And I get that by taking 15%. So 15%, remember, as a decimal is 0.15. If I take that decimal twice to the right, changes it from a percent to a decimal. And if I take that 0.15 times the 300 number, I'll get the total that do not like ice cream. So 300 times 0.15, that gives me 45, which goes in this box right here. The total that do not like ice cream, 45. All right, the next one, 1/20th as a fraction. If you divide that, 1 divided by 20 gives you 0.05 as its decimal. Don't change it to a percent because you want to leave it as a decimal. Times that by 300, and this is going to give me the total students who did not like ice cream and do not like cake. So that one you're going to have to find the intersection where people do not like ice cream or do not like cake. So if I do that, 0.05 times 300, that gives me 15. That number goes right here. And then I have the last one, a total of 150 indicated liking cake. So the total for liking cake goes right here. So the total students who like cake is 150. And now I have enough to fill in my table, because remember, they plus going this way, they plus. they plus going this way, going down, they plus going straight across. So if you have three of the numbers, you could just do simple algebra. 300 minus 150 gives me what that number would have to be right there, 150, because 150 plus 150 gives me 300. That's why it's 150 right there. If I go up and I look at some number plus 15 to get 150, again, simple algebra, 150 minus that 15 gives me 135. That goes in this number right there, because 135 plus 15 gives me that 150 number. Now I could just keep doing the rest. If I take 300 minus 45, that will give me what that top number is. So 300 minus 45 gives me 255. And if I look at the rest, the only number that adds to 15 to get 45 is if I take 45 minus 15 gives me 30, because 30 plus 15 is 45. And then that last one, 150 minus 30 gives me 120. And then they should all match up. 120 plus 135 should equal 255. It does. 30 plus 15 should equal 45. It does. 150 plus 150 equals 300. And then adding down, these two added up equal 150. These two added up equal 150. These two added up equal 300. Know that. That's how a two-way frequency table works. All right, moving on. 19. Here we go. So for 19, again, looking at what slope is, this is the slope number. That 1.8 written as a fraction is 1.8 over 1. That 1 is really my run, and then I got to use this. This is 1 inch for my run, and then my rise is about 1.8. Not very much, but that is pounds. That's where I'm getting these units for that line right there. Every time I go over 1 inch, I'm going up about 1 pound. So this is 1.8 pounds for every 1 inch. That's what this means. This graph is showing that every time this dog grows by an inch, it's adding 1.8 pounds to it. Every time it grows an inch, 1.8 pounds added to it. Let's look at these choices. For every additional pound, the dogs grow 1 inch. That one is jacked up. That's if I add inches on top and pounds on the bottom, then it would be 1 pound gives me 1.8 inches, but that is not correct. This one, when dogs were born, that is a time unit. None of these units have anything to do with time. For every additional inch, the dogs weigh 1.8 pounds heavier. There it is. As you go up an inch, your pounds go up by 1.8. And then this last one, look, this is another time. There's no time issue. Time would be like hours, weeks. None of these units, inches, pounds, talks about time. So throw that one in the trash. All right, next word is hills. Hills. All right, almost done. Number 20 wants you to find the y-intercept, which is this guy. And your y-intercept being 0, 20. Your x number for this, hours. Your y number for this, points. So what this means, as someone who studies 0 hours gets a score of a 20. That's what you're looking for. Let's look at these choices. A student who gets a 0 spent 20 hours studying. That's a joke. Why would that happen? A student who studies 20 hours gets a 0. That would be a jacked up class right there. A student who does not study, that would be like 0 hours, receives a 20 score. There it is right there. That's 0, 20. 0 hours, 20 test score. This one right here is jacked up because it has 1 point for every 20 hours of study, and that is not true. That I would not register. All right, here we go. Moving on. All right, correlation coefficients. This says Archie. If if I could get my glasses here, sorry. Archie's line is 0.95, and then it has Nate's line, which is 0.97. Remember correlation coefficients. The closer it is to 1, the tighter the data is, the better correlation coefficient. Remember, +1, perfect line, positive slope. And then as we get in the middle, the points get a little bit more scattered. As we get down, as I'm going down the scale, the points get a little bit more scattered around. I'm hoping that's how you see, that's how these correlation coefficient problems work. So this one, 95 is not more than 97. That is not true. Archie's line does not fit better. It doesn't show it. Next one, Serena's line. I'm sorry, Serena's line is 0.9, and then Jana's line is 0.93. It's trying to tell you 0.9, Serena's line fit better. 0.9 is more than 0.93, but that's not correct. All right, last one, or next one. It says Nate's line, which is 0.097, pretty high, compared to Jana's line, which is 0.93. Nate's line fits better, and you can see this is the only one that really has that true statement. Nate's line fits better. Nate has a higher correlation coefficient. That is correct. The other one, Serena's line 0.9, and then Archie's line 0.95. Again, that is false, saying 0.9 is more. That's what you need to see if it fits better. All right, moving on. Last one, fitting the numbers in the correlation coefficients. This 0.97, I'm going to put right here right away because I can see this is positive and pretty tight dots, almost a straight line. This one is negative, so the only ones I have that are negative to worry about are these right here. And I can see those lines, they're not super tight, man. Negative 0.8 would be a straight line. Negative 0.15 would be pretty scattered going negative. So I'm going to use negative 0.75 on that one. Let me get rid of this. So negative 0.75, I think matches that the best. And then I look over here. This one is going uphill. So the only uphill ones I have now are this guy and this one, and there's no way it's 0.05. That's super scattered. So this one is 0.74. And then, of course, my last one there I could see has it super duper scattered. So the very, very lowest one is that 0.05. That's how I'm going to fit those in there. The last word is blue. Blue. Thank you for listening. Show me this. I'll give you your 500 points. Good job.